Hello students, Miss Slyman here, talking to you about the unit circle. The unit circle is super important in trig and gets referenced a bunch. And, well, I say it gets referenced a bunch and it's super important, but really it's just a way of putting together the idea of angles in all quadrants. So don't be afraid of it because it's really just a circle centered at the origin with a radius of 1. So this radius is equal to 1. If we think back to defining sine and cosine, well, we said sine of theta is opposite over hypotenuse, but since our hypotenuse is now 1, we can just say that sine of theta is y. Cosine of theta adjacent over hypotenuse, so just x. Tan theta, y over x, which is my slope, if you notice, because that's my rise over run, is my y over x. All right, so why do we care about this? Well, we care about this because if I know coordinates on the circle, then I also know a sine value and a cosine value. Additionally, if I know where I am in the circle, I know if those values are positive or negative. So for example, if we had an angle of 5 pi over 4, so there's pi, and if I add another pi over 4, I end up down here. So this angle, 5 pi over 4, my reference angle is pi over 4. Well, we know that sine of pi over 4 is root 2 over 2, but sine of 5 pi over 4 is a negative value, and it's going to be negative root 2 over 2. Cosine of 5 pi over 4 is also going to be negative because I'm in quadrant 3, but it's going to be the same as my reference angle of pi over 4, so I'm going to get negative root 2 over 2. So these coordinates on the circle also give me the cosine and sine value for the corresponding angle. And really what's helpful, again, is figuring out whether you're in a situation where your sine value is negative or your cosine value is negative. So going around the circle, I could label all of my special angles, like for pi over 6 is my short angle. I could put that in down here as negative pi over 6, or alternatively, 2 pi minus pi over 6, which is 11 pi over 6. I know those ratios. I've got short side is a half, but I'm in quadrant 4, so that's a negative value. My x value is long and positive. That's my root 3 over 2 value. So the circle can also help me think of those measurements because I know if I go down just pi over 6, then I know where my longer side is. It's on the x-axis. My opposite side is going to be the y height, and going down just a little bit in the circle really helps me to think about the size of my sides. So cosine of negative pi over 6 is positive root 3 over 2. Sine of negative pi over 6 is negative 1/2. So that's what we use the unit circle for. But unit circle can also help me think about these properties. So if I go around the unit circle thinking about my sine and cosine values, well, my domain is the input of those functions. So the input is theta. Well, theta has no restriction. I can go around as many times as I want in the positive or negative direction. So theta is an element of reals. My range for sine theta and cos theta, well, I know that sine is my y values, and those are bounded between negative 1 and 1. Cosine are my x values, bounded between negative 1 and 1. So the range for both sine and cosine are negative 1, so that's sine theta or cos theta. That says or. They're both between negative 1 and 1. My period is how long it takes for things to start repeating exactly. So all of these coordinates don't start repeating exactly until I get back to 0 degrees or 0 radians, and that takes going around 2 pi radians. So my period is 2 pi radians. All right. The unit circle can also help us think about our trig identities. So we said that the tangent was y over x, but we also said that y was sine theta and x was cos theta. So this is the first identity. We're going to do identities more next unit, but these two are super important, so we start with them in this unit. Tan theta is sine theta over cos theta. The Pythagorean identity, well, that uses Pythagorean theorem. I know that Pythagorean theorem says that x squared plus y squared is going to be 1 squared because unit circle is 1. But x, again, is cos theta squared plus sine theta squared equals 1. Normally, I write this as cos squared theta sine squared theta equals 1. And we can rearrange it as much as we want. So for example, I could also say that cos squared theta is equal to 1 minus sine squared theta, and we still would call that a Pythagorean identity. So there's your introduction to the unit circle. We'll come back more with some more examples in the next video.